Hello, everybody, and welcome to SkyTour live stream for tonight. It is a wonderful Wednesday, July 19th, 2023. And of course, the night is always complete when we know we have somebody else with us. That would be Daryl Mason. Hello, Daryl. How are you?
Hello, Mark. I'm good. You? Hello, everybody.
All right. Well, it's good to see you, man. And I know that we're going to have some fun tonight because we've got a lot of cool sky coming up in the summer here.
Uh huh.
Yeah. So
From here, Antares is west of the meridian by 10 p.m. now.
I know, isn't that cool?
Uh,
Means the
uh,
Sagittarius Milky Way is going to be at the meridian. That's what I
yeah.
think.
Vega transits the meridian at midnight now.
Yeah, we got some beautiful summer sky to check out. I see we got people already. Hey, Cyclone is with us. Alice Pooper and Michael Hedrick. How you doing? Marianne Robb, what are you doing here? Hi, Marianne. Marianne's cool. Marianne was talking to me about uh, a possibility earlier tonight. And in fact, two other people that are friends and in the biz, so to speak, suggested that maybe it's time for us to consider uh, an addition to SkyTour Livestream that might take us into television. I thought that might be a cool way to take SkyTour Livestream to the masses, just to make it
How
a
would you
show.
do that?
Well, they would be recorded shows, and we would cover different objects, and it would be written for everybody, so people could come on in and check out cool things and see them in the view. For instance, supernovae or asteroids or nebulae, like this one. That's a nebula right there, guys. That's you can't tell, but I will show you where we are in our. I'll bring up my planetarium. Okay, because in here, all right, we are just above Antares, which is the eye of the scorpion,
Art.
heart of the scorpion. Yes, I know. I know that, and I said it anyway. It's weird. Sounded wrong. And we will be exploring this region right here, which is actually the Pho Ophiuchi Nebula. And we are down just a little below it. And Pho Ophiuchi is just out of shot to the top. And we're going to be focusing on these stars right now. These are stars that are pretty interesting. And there's an Antares Nebula, which is down here. You'll see it. And dust all throughout this region. And it's not quite dark enough yet, but I'll try to give us a exposure of maybe I'll try 25 seconds and see. It's still sunsetting out there, so we're going to have a halo of red around this image most likely, but we'll see. So how's it going up there, Daryl?
It's been mid 90s here the last couple of days.
Wow.
That's hot for here.
Yeah.
We'd be as bad as you are in Arizona if it wasn't for the altitude. That's the only thing that keeps it cooler here.
Yeah.
But it's supposed to start cooling off tomorrow, and then by Friday it's supposed to be quite on the cool side, I think.
Wow.
Down in the 70s, so that'll be a nice break.
Cool.
I think the monsoon is trying to start because it's clouding up every afternoon now. Might or might not rain.
I gotcha. Well, I'm actually in Connecticut right now, so the temperature outside is still about 70. The temperature in the building, that's 70 Fahrenheit. The temperature of the, oops, sorry about that. The temperature in the building out there is actually 36 Celsius, so it's over 90, 95, right?
Yeah.
In the building. That's pretty warm.
I see that. Yeah, it's cooling off at night here now though, so it makes it tolerable.
Yeah, and you'll notice down here, which you can read when you go into. Make sure you're in 1080p mode, guys. Okay, just make sure. But if you look down here, you can see that our target temperature is minus 10 Celsius on the sensor, but it's only at -3, and it's running at 100%. So at 100%, it can only get down to -3. Now it's -3.4. So it's gonna trickle back down, and we'll get a good well, we try to get 30 degrees below ambient temperature if we can. And there we go. Now we're getting some more of this nebula. Look at that beautiful nebula. The vast Antares Nebula is here. We're seeing part of the Alniyat Nebula maybe over here, a little bit it's down below here. But it's pretty cool. Yeah. This is a region of dusty, cloudy space. And many of these areas that we're looking at are full of these dark nebulae. These streaks will become a little more clear as we stack more than 5 images. You can see 5 images are stacked right there. That's that right there, that number 5. Now it's 6. Okay, we take an image, then we take a second, and then we align it with the first, line it up, all the stars to make sure they're all lined up with each other, and then we just stack more and more images on top, and we go all the way up, bing, 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 and we end up making this amazing image sandwich that reduces a lot of the noise. You can see now, even as we're talking, the noise in here has been reduced quite a bit. So it's pretty cool. Very nice. And then we have Alicia's with us. Hello, Alicia. Thank you for the nice comment on our photo that we put up earlier. We put up 3 of the pictures from the stream on the 13th of July. Yeah, we did that. It was pretty cool. Rocket City's with us. Sam S is with us. How you doing, guys? Yeah. Yeah, look at the beautiful... I just love how these beautiful black dust lanes meander through the galaxy.
Oh, yeah.
Yeah, it is really pretty.
I've said before, if you had a wide enough field of view, those dark lanes wander all the way over to the east, to the left,
yeah,
and wind up at the Dark Horse and the Pipe Nebula.
Oh, yeah.
Just west of the Milky Way.
Yeah. Okay, you know what we're going to do? I'm going to remove the scope here and just pull this over. Okay, and I'm going to drop our stack out of the way, and we're going to enlarge this just so you can see it. Like, look at now, you see the beauty of it. Look at that. Amazing. That is just gorgeous. Wow, really cool.
Mm-hmm.
So, folks, I hope that you guys have thought about the possibility of joining our Patreon. We have a number of people that have joined already. Love to have you if you're willing to. It's as little as $5 a month. We need to pay for our internet and so forth. And I do want to thank our patrons listed here in this list. Ta-da! There they are, right there. All right. And we're looking for more. We'd like to see more people join us and support us. I see some of these sites that do far less than we do, and they've got like 100 patrons. How do they do that?
Oh, distaste is the best taste in the world. Some of the most juvenile channels I've seen on YouTube have oodles and gobs of Patreon supporters.
I guess that's true, isn't it? I guess that's true.
All this common denominator sort of stuff,
Yeah.
I need to sign up on Patreon. Maybe it would encourage others if they saw my name in there.
Oh, well, you've actually donated a lot to us.
Well,
your time and a private donation. I mean, you're actually very prolific with all of this stuff.
Oh, we'll see. I just think it's like advertising.
Yeah, it is. It's wonderful, Okay, we've stacked 15 so far. And if you want to know where these pictures go, they go to on SkyTourLive.org. They as I save them, they are shipped out of the observatory, go up to the cloud, and drop into our online server that you can find at skytourlive.org, where it says "Take me to cool pictures," and it'll take you to the server, and you can sift through the directories and actually see that very picture you're seeing right there, made available to you. Now, what we do, of course, is we will spend a lot of time to process these and make them look even better. And if you're a Patreon member, you get to see and take down the highly processed images that are suitable for turning into framed images and stuff. But we also offer those as well. Again, skytourlive.org, you go down a little further and it says, I want to buy these cool pictures. You can actually buy them too if you want to. Marianne is the worst offender. I think she's probably bought most of everything we've done as a big canvas print. But again, she is the treasurer of our nonprofit organization, so I guess she does. Hello, Creeptasia. Good to see you. Good to see you guys. And Dagger's with us. Hi, Dagger Spells. What's up? Nice to see you. So, yeah, we're just doing a preliminary view of the summer sky. If you notice, it is now very dark. It's dark enough to see some gorgeous imagery. And we have this beautiful reflection nebula up here. Right above it, out of shot, is Pho Ophiuchi, the actual stars themselves. And there's a blue reflection nebula around them. You can see it right here. And we're gonna do a stack of 20 of these, and then we're gonna go up to Pho Ophiuchi and do another stack to then capture Pho Ophiuchi, and then we can mosaic that. There's nothing like a beautiful mosaic of these guys. So what we're going to do now is we'll just bring our live stack back into the dock position, and bring our telescope back for a second. There we are. Okay, and now what I'm going to do is I'm going to pause the stack right there. I'm going to come up here and I'm going to say Pho Ophiuchi. All right, so let's see. Yes, stacking is paused. All right. Pho Ophiuchi. All right. So now we can save it. All right, that beautiful image with 20 exposures stacked together is now going to be saved. Oops, I tried to save it again, sorry. Then save it exactly as seen. There you go. So out on the server, this is the image you're going to see. That one's up there for you to take. Oh, look at that. It says North American Nebula. Well, that's not there. That's actually a label that doesn't belong there. Okay. There we go. So that's up there, heading up to the server. All right. All right. So now what we're going to do is we're going to clear this and go back to our night vision mode and head up a little more to the north. All right. So let's go into night vision mode here. Okay. There we go. And now what we're going to do is bring these two stars, which have that nebulous detail around them, all the way down here. And you'll see Pho Ophiuchi come right into view. Here we go. I want to thank you all for coming out, by the way, to check out what we're doing tonight. We absolutely enjoy interacting with all of you. I have a great time. Oh, Izabela. Ah, there she is. I didn't hear what you said. There's Izabela. Hello, Izabela. Welcome to you. We're doing a mosaic just for you, Izabela. Look, there goes a satellite right there. Okay, this is the stars. These are the stars Pho Ophiuchi right here. Okay, and Pho Ophiuchi is this star right here. And these two, I have to look and see. I don't remember whether Pho Ophiuchi is actually a double star. think it probably is. But these stars may not be doubles there. I'm not sure. I'd have to look that up. Okay.
Give me a second. I'll find out.
All right. So we're going to do the same thing. We're going to actually do a 25-second exposure of this one as well. And we're at a gain of 250, by the way. And just as a reminder, so you can see what's what, okay, the most important elements that we look at are this guy. This is the exposure time right there. And this is the gain right here. And the gain and the exposure, we play off of those. We have high gain and high exposure means a noisy image. But long exposure with a low gain means that we don't have a noisy image. So there's a happy medium, and that's what we do. So let me pull those out. All right. So now we're going to start this shot, and this will be 25 seconds. And we're going to get out of our night vision mode. All right. Start up our stack.
Pho Ophiuchi is a binary.
With any of those stars that we see?
Pho
Or is it a spectroscopic binary?
Ophiuchi AB is a visual binary.
Oh, okay.
And there may be more stars in there. Consists of at least 2 blue-colored subgiants of main sequence stars.
Excellent. Look at that. Well, we're going to get rid of that because we don't want that. Yeah.
They take about 2,400 years to complete an orbit about each other.
Wow. I'm going to get out of this because I realized I want to go a little bit higher to get the rest of that blue nebula in there. All right. So we're going to go right here and go do a 1 second shot again in our mode here, our night vision mode. All right, and the pics we want to use, we're going to do 1 second. All right, so we're going to move a little further north, and those bottom stars will drop out, but that's fine. I just want to get all this nebulous detail in here. It certainly will be easily mosaicked. Simon Thompson's with us. Hey, Simon, how's it going? Good to see you.
I'm going to post the Wikipedia link to the Pho Ophiuchi cloud complex.
Okay.
The top picture has the new web image, which I think is just a knockout picture. If you see that picture at the link, folks, click on it to enlarge.
And that'll take you out of here, so make sure you don't lose us.
Oh, well, wait till later or open it in a new tab or window.
That's all right. It'll be there later anyway.
Yeah.
Hey, Louis TA, what's up? And Mazif, how are you? Good to see you guys. Okay, we've started guiding. 25 seconds is our goal. And let's do it. And now we'll come out and go into our live stack here. And now we wait for our first images. I hope all of you are doing well tonight. We're having a good night tonight.
Pho Ophiuchi itself may be as many as, let's see, there's the main pair AB.
Yeah.
There's another one called HD 147932. It's known as Pho Ophiuchi C.
Okay.
Pho Ophiuchi DE. So it's a double, I guess. And stars C and D are both B-type main sequence stars. T itself is another binary with an orbital period of around 680 years.
Okay.
So there's at least 5 of them there, I guess.
Wow.
Anyway.
Thank you, Daryl. That's cool.
Sure.
Yeah, thanks, Sam. Make sure you hit the like button, guys. Get us noticed out there. We want to actually continue this for you and make sure that what we do for you never ever has to go away. Let's do the same thing we did before. Let's take the telescope out of here for now. Okay, and then let's undock this guy, show him down. And now we have our screen. We can see it. This is Pho Ophiuchi right here. And this is a blue dust cloud that's actually being illuminated because of these Pho Ophiuchi stars. And what's happening is these are all dark dust. And this dark dust is actually being scattering the starlight. And it really, really is pretty interesting how that happens. You know?
Says one of the stars in the AB pair, I think, is emitting X-rays.
Oh.
That may be helping light stuff up some.
I think that could be true. That could be true. Okay, let's see here. Don't worry, Daryl. There you go. Okay.
What, me worry?
Oh, me worry, Alfred E. Newman.
Yep.
This beautiful Gossamer Nebula, this blue area over here is characteristic of dark dust when it gets near a star that's got some blue light in it. Most stars do. And these stars will send out a lot of blue light, and this dust will scatter that blue light. It lets the red through, but it lets the red go onward, I should say, and then it absorbs and re-emits the blue light in every which direction. So this blue is blue for the same reason our sky is blue, as I've said many times. So we see this happening, and that is a scattering process that causes this to happen. Let's get a little bit more detail in here. There. So now you can actually see the wispiness coming in right here. You can see all this wispiness, right? And as I mentioned before, this is Pho Ophiuchi here, right? And there could be several components, as Daryl said, because he looked it up. But take a look at this blue. This blue all around here, that is the Reflection Nebula. That's the nebula that the dust in this cloud, this is all a dust cloud in here, all dust. Everywhere you see is dust, right? There's some hydrogen gas mixed in that is emitting a red light as well. It's a hydrogen emission that's happening there called hydrogen alpha. And that's because the stars are hot enough to ionize the hydrogen atoms that are in the cloud. And that makes them glow. And that's really interesting how that happens. You can see this dust out here. All right, there's a lot of dust out there. And you see dust coursing through here. There's a more dense area over here of dust. And it just goes down. You can see the streaks heading to that light patch that we just imaged. So this is really just the most amazing nebula. And the thing that's interesting, how do you know when you're in the dust? If you look at the color of the stars you see in here, they tend to predominantly go toward the orange, don't they? That's because many of these stars are embedded in this dust. And what's happening is the dust is reddening the starlight. Just like particulates in our atmosphere can make our sun look red at sunset, along with the scattering process we talked about. This dust will cause what's called interstellar reddening. And that reddened starlight is very evident here. You can see how many of these stars are much redder. It's not that there's tons of orangey red stars here. There's not. There's a number, a fairly good number, but not all of them. So this is why when we look at this, we know we're in a dust cloud because we're getting this reddening going on here. Now, as we've gone to 14 stacked images, you can see the details now coming out in this cloud. Look at that. It's becoming quite detailed. See that, Daryl? I like this dust cloud. What do you think?
Sorry, I was muted there.
I knew it. I didn't want to say it. I didn't want to embarrass you.
I see it. Now,
Yeah.
Albert Einstein supposedly once said, my sense of God is my sense of wonder at the universe. And that's a really good example right there.
Yeah. It is. This and the previous exposure was pretty interesting that way. You know, really cool. Okay, we have.
What you were just saying about red stars.
Yeah.
I've noticed a lot of red stars in other recent images. Are
Yeah.
they, most of them pretty much for the same reason as what you said?
Some of them are going to be interstellar reddening, like we see here. Okay, but there are a very, very large amount of these red dwarfs out there anyway.
Well, there's more red dwarfs than anything else.
That's correct, right? They're the most copious star in the entire universe.
I guess it's just a matter of us seeing them.
Yeah, and you can't see a single red dwarf with your eyes.
Yep.
You can only see them in a telescope or through a time exposure like this. Certainly, some of these stars are red dwarfs. Okay, and some of these are carbon stars. Most likely, possibly. And I know that Izabela has taken a shine, as it would be, to carbon stars. And we did a whole show on SkyTour Radio about carbon stars.
Mm-hmm.
That was like last year, I think.
Yeah.
But carbon stars are very interesting, and they're extremely red. They look like an unearthly reddish glow.
Yeah.
And and look, we have carbon star here as well. Carbon stars, you say? Yeah, there you are. And so carbon stars are very interesting because they represent a star that's in what's called the asymptotic giant branch, and the star has puffed up to become a red giant for a second time in its existence. And when it does, it tends to be so distended, so big that molecules can form in its outer atmosphere of carbon. Now, there's several isotopes of carbon that you'll find in the star's outer atmosphere, and it's the ratio of those isotopes which tell us what point it is in its evolution. So, if the ratio of a particular carbon isotope to another is at a certain number, it indicates that the star is in the first red giant phase. If it's different, it's in the second red giant phase, and what we call that asymptotic giant branch. And so, Samus, I think Daryl's probably answering you right now.
Yes.
And so, when we talk about the actual amount of carbon, the reason the carbon's there has to do with the way the star actually transported that carbon to the surface. And this is called a dredge up. All right, and there's a couple of dredge ups that you can get or more with a red giant. And sometimes the outer layers are convective, like a pot boiling, and the stuff in the interior gets dredged up to the top and flows over the top of the star, and so we see those different isotopes out there, and that's what's cool. I'm gonna pull this back now, get my telescope back, and get us back into our stack here. I'm gonna pause this.
Yeah, Izabela got me thinking about carbon stars the other night, and I meant to tell you, Izabela, about the star Mira. Maybe
yes.
we can see later in the summer here. It's Omicron Ceti, constellation Cetus the whale, Cetus the sea monster in the Perseus Andromeda mythology. Mira is a variable star. It's very red. There's a beautiful picture of it at the wiki page for Mira, M-I-R-A. It means wonderful is its name. Uh, it's a variable star. It varies in brightness quite a bit. And there's a whole class of stars named after Mira variables. Some Mira variables are carbon stars. Mira itself, I don't think, is actually a carbon star. It's all involved in oxygen versus carbon ratios in the star's atmosphere.
Yep.
If there's a lot of oxygen, it's not considered a carbon star. But if there's lots of carbon, well, it is a carbon star. There's a beautiful apod from a couple of days ago, too, of star in Leo. I forget its designation. I'd have to go look it up. Extremely red star with all sorts of folds of gas and carbon around it. Beautiful picture. Let me go find that. This picture is a real knockout. C.W. Leonis. I will post a link.
We can't see that now. It's probably set.
Yeah. Leo's going
Hello,
away
David
for
Schmidt.
the season.
Nice to see you. And Marco's with us now. Hi, Marco and Tim F. Good to see you guys.
Yeah. This is a Hubble image. It's a real knockout. Take a look at it when you get a chance. It reminds me very much of a planetary nebula, but it's evidently all carbon, or mostly carbon.
Yeah. So now you can see how absolutely clear these filaments are. And I'm going to save it one more time anyway, just to have it. I think that looks really pretty. Really gorgeous. All right, so this is Pho Ophiuchi region. And while we're here, I think we should probably pop down to a Measure 4. Which is right down here. Now, we went and we looked at IC 4603. We had this IC 4605 here in our view. And if we keep going down, we'll get Alniyat in there. And we'd have to go another set of exposures to get to Measure 4 and Antares. But Antares is exceedingly bright. And Antares really makes a mess of the image. It's so bright. But again, it's a red supergiant, right? So hey.
Yeah. You can see in the stellarium image here all the nebulosity around Antares being lit up by Antares.
Yeah, that's the Antares Nebula. Yeah, that's right.
Yeah. And when you see Antares there, that's the other really good supernova candidate in our skies.
Yes, it is.
It and Betelgeuse, and they're rather similar stars. Both are red supergiants.
Mm-hmm. All right, so we're gonna get out of this. We got it saved. It'll be up there as Pho Ophiuchi, listed right up there. Make sure you're in 1080p, guys. And now we'll go back down to our night vision mode here. Okay. So let's go and move ourselves down. Alniyat's actually a good place to go. We can drop down to Alniyat. And after that, we'll drop down to Measure 4. And then we can have a whole set of imagery that we can use here. And we'll include Antares, even though it's going to be problematic. There's Alniyat. Okay, and we're going to move Alniyat over a little bit because the nebula we want to look at is off to the left here. Okay. Oops, wrong way. Wrong way, Feldman. Okay, I'm going to go this way.
The other left.
Yeah, the other left, yeah. Because we're going to be looking at the Alniyat. Oh, wait, that's the wrong side. I got the wrong way. Okay. Fair enough. All right. I guess I have to go back over to the other left.
Oh, I thought this was the other left.
I thought it was too. But you can see the nebula here. I should have seen that. Okay, so I'll just drop us down a little bit, southward more. Still within range to do what we want to do. Now we're going to do the obligatory 14-second wait, 11 to 14-second wait to get our guide star. Oh, by the way, folks, we have solidified the equipment we're going to use for the next telescope. And it's going to be pretty phenomenal. And just so you know, the camera on this telescope is changing. We're getting one that is going to allow us to zoom in even more and see more detail. It's the perfect camera for matching to this particular optical setup. We don't have the perfect camera at this point, oddly enough, but now we're going to. So that's next. All right, this will be a 25-second shot. And we're going to pop out of this. We're underway. You can see by the yellow progress bar down there in the lower right. Okay. And we'll go into our stack. Ah, that's beautiful.
MSN offered me a page from eBay showing a Celestron C11 Edge.
Mm-hmm.
Was $4,399.
That's cheaper than normal. Is that just an optical too?
New or not?
Oh. Now you see all the modeling in here? Okay, this modeling. Watch in a second here as we get this next shot in 1 second. Watch how this goes away. It's going to go away. Yeah, look at that. So now the nebula is a little bit more clean. And as time goes on, as we stack more, the data that is to be, on the photo will actually rise to the top and make real nice strong peaks. Right now they're kind of flat, but as we make more exposures, they're going to get pointier and pointier peaks. That data is going to end up coming out, including the dark nebula that might be in there. And so that's why stacking is so helpful. So the modeling is going to all but vanish here in a little bit, which is kind of cool. I'm going to...
Mark, take note of what Izabela said to me.
Okay.
The software refuses to stitch Pho Ophiuchi images together.
Well, it says it doesn't match. You might have to fool it, Izabela. I had to do that too in a couple shots, and I know what you mean. Like, what do you mean fool it? I'd have to show you. Because it does do that, and they do match. I think it's because it's more dust, and what you might have to do to fool it is to actually do some processing on it first, and bring out enough of the stars that are hidden in the background there to actually make it work. I know that it's a pain, but that helps a lot. Look at this now. This Alniyat Nebula is now taking on some characteristics of its own and some beautiful character. Really cool. They are quite different in color because the regions I was taking pictures of are effectively two different colors. Pho Ophiuchi is very blue, and the center area of the Pho Ophiuchi complex is more of a whitish You know, so that's kind of tough. Wow, Lewis, that's cool. You're watching from Vietnam on vacation. Who would watch us in Vietnam? Isn't there other cool things to do? It's got to be in the middle of the day and over there, right? I'm gonna guess it's was it? You got to be from me on the East Coast in the United States. You got to be 9 hours ahead of me, maybe more. That is just so cool. Yeah, look how beautiful the Alniyat Nebula is turning out here. I'm going to leave this all in the Pho Ophiuchi because we'll make it all one big happy family.
It's 11:44 a.m. in Vietnam.
Okay, so I said, how many hours? 8 or 9?
You said 9 ahead of you.
Okay, I'm at 12:45, so it's even more than that. I was just guessing.
I guess 11 hours ahead of you.
Yeah. Actually, that makes sense because Australia is like 12. He says 12 hours behind.
Depending on your point of view.
Mm-hmm.
Well, it's the other side of the international date line, Lewis, so strictly speaking, you're ahead of us. It's tomorrow already over there.
The date is the 20th for you. Or no, 21st. No, wait. No, I think because we're after midnight here.
So you're the 19th already, and
I'm the 19th now. You're the 18th. So
18th here, so he's the 19th.
He's the 19th, yeah. Hey, RGPX, how you doing? Oh yeah, people. We have people from China, and of course Izabela's from Bulgaria. Daryl's from Colorado. That's a country all of its own. I'm from Connecticut. That's not worthy of anything. Hey, Desert Dweller. Good to see you, man. Yeah, look at this. Look at the Alniyat Nebula. Look at now how clear it is. Remember all that noise that was up here? Notice it's gone now? That's with 13 stacked images. Really pretty. Oh, the circle around the star, Creeptasia is asking. That's a halo caused by our optical system. And we have a way of removing that very elegantly. Which we'll do. But you get access to the one that has the halo in it. If you join the Patreon, you actually get access to our processed images for the upper levels. And you get to see everything. That's really cool.
You know, I mentioned the other night I thought I saw a new sort of diffraction spikes in an image you showed.
Yes.
And I see that here too. They're like 2 vertical spikes.
Right there. You also have some additional ones
spikes.
there.
And diffraction spikes form at right angles to obstructions. So the cable lines you see there, the dark lines, that's what's making them.
Yep. I haven't done any of the fancy cable routing. They actually have a way to minimize these by making a special curved cable routing.
Yeah.
And I saw the differences, and it's not enough to worry about. It does alleviate it somewhat, but the next telescope's not going to have any of that. Nor will it have these halos. But that's because it's going to be a longer focal length, meaning it's going to have more magnification. So we're going to see a field like this size or so, maybe a little bigger. You know, and not this whole thing. This is 2 degrees across and 1.5 degrees tall. That's 4 full moons and 3 full moons. So that's a lot. Big size. We're going to have a lot less than that. We're only going to have an image that's just about the size of a full moon. Maybe a little more, because we're going to actually take it from its native F8 or 10 and drop it down to F7. So it's going to be faster. Okay. We're going to pause this here and save this. And we'll save exactly as seen, because that's 20 shots of Alniyat. Okay. So that's up there, heading up there. Now what we'll do is we're going to head to our new region now. We're going to drop down a little more here. And there's M4 coming right in. And we'll head east a little bit. M4 is a beautiful globular cluster.
Oh, yeah. One of my favorites. See the halo around Antares.
Yeah, I know. I'm debating whether I want to bring it in, because it's going to extend all the way out into here.
Yeah.
Why not? I mean, we'll test our ability to get rid of it. All right, that'll do. Okay, so let's do another 25-second shot here. We're getting our guide star, so it's saying searching, searching, searching. Then it's gonna zero everything out. You'll see 4 zeros with periods between them. And then we'll be ready to guide.
Can you see the vertical line of stars in M4 center, just on the snapshot?
Right there.
Or the live image.
Yeah, you can't miss it. There it is.
Yeah.
Okay.
Simon Thompson has a question for you.
Simon says, are you going to share what the new setup is? No, that's not. Of course, I probably should have. It's going to be a Celestron 11 Edge system, and it's going to be running at F7 because it's an Edge. If I went with a regular 11 without the very, very crisp imagery all the way to the edges of the field, then we would be actually able to run with a F6. But we're going to do it this way because we would like to have the edge. All right, so it's a Celestron 11 Edge, and we're going to be doing something called off-axis guiding with it.
Really?
And yeah, with a guide camera that's going to be doing the guiding. And we're also getting a rotator for the field. That's a new thing you didn't hear me say before, I don't think.
No.
Yeah. We're gonna get it. We're gonna get a guiding. We're gonna get a rotator that's gonna actually be able to rotate the prism around. The way it works is you got the barrel of the telescope, right? You have the barrel, and then you got a little tiny mirror that sticks down just a little bit into the field, and it takes a tiny bit of the light and a tiny bit of the field where you see all these stars, and it picks one of those as a guide star, and it guides on those. All right, but what if you don't see a star? You have to be able to rotate that little mirror around inside the barrel in order to get a potential guide star. And that's great because what that'll also allow us to do is to shoot in a portrait or horizontal, landscape mode with the camera.
Hope you compose shots, I guess.
Yeah, but it also the primary use of it is to actually manage the auto guiding. It's for the off-axis guider.
Yeah, I understand. Have you seen that? I forget who. One of the Astrocam makers. They're offering a camera now with an integrated second chip for auto guiding.
I think that's a great idea.
Yeah, there's the big sensor, the main sensor, and
Yeah.
then just like that little prism is, hanging at the edge of the field of view as you're talking. Instead of that little prism, well, there's a second smaller chip off to one side of the main chip, and that's the auto guider and this double sensor camera.
I think that's what Simon's talking about. Is it the 2600
Yes, I see
MC
that.
or MC Pro or M Duo,
Yeah.
whatever it is? Yeah, that's pretty cool. I will say this. SBIG, Santa Barbara Instrument Group, made some tremendous cameras, and they still do. And I had the SBIG 2000XM here. And that can look at the sky and use the very same field that it's looking at in imaging as its guide to guide with. So it does dual guiding, and every one of their cameras was doing that. My ST4 did that. The SBIG 2000XM does that. So I kind of thought, well, any CCD camera or any CMOS camera you buy, you should do it as well. But there's an issue, and that has to do with the time of integration, the time it takes for it to get the image in. That might cause it to not be able to do it. Yeah, see, Simon says he has the 9.25 Edge with a 7 reducer. It's a great setup. Yeah, and the ZWO Duo. I think that's great, Simon. We're actually building a new enclosure. We're not going to have a building like you see here, like you see here with the roof off, and the telescope in there. We're actually building an enclosure that's going to just go around the telescope itself and open up like flower petals and allow the telescope to basically sit out in the open. So we will be able to see objects near the horizon, if not on the horizon, from certain angles. But there's no use to that practically for photography or astronomy because we don't typically do that. But for people that want to see some cool objects, we'll be able to do it, and that's kind of neat.
Ray has a question for you.
Is Ray
A
here?
guide, Cosmic Ray. He says a guide scope is not good enough? Question mark. I would assume that's because of the higher magnification.
Well, no, a guide scope would certainly be good enough. The only problem with that, Ray, is we've got a problem with what's called mirror flop. Okay, as the telescope's moving, okay, the mirror can make minute changes and minute positional changes, and that is something that you don't have a problem with a wide field scope like this. But when you're as you say, Daryl, when you're in a higher magnification, mirror flop is a problem. And so you will end up having subtle deviations in your mirror, and that will cause problems. So we have to do off-axis guiding to be the best at what we do. Yeah, and that's actually a very good question, actually, Ray.
That actually raises another question, though. With the Edge, I wondered about this and forgot to ask you. I know the Edge telescopes have 3 locking knobs to secure the primary mirror, I think, to prevent mirror flop, isn't it? But you probably can't use those to lock the mirror down at a remote observatory, I assume.
Well, unless you leave them locked down the whole time. All right? But the thing is, you got to be able to focus. And if the mirror's locked down, to run an autofocus where the mirror's being moving is a great recipe for just shattering your mirror. Don't want to do that.
No.
So we have to let it all float. We have to let it acclimate. We have to let it change temperature. So that's important to do. But no, And by the way, the camera we're using here is actually ideally suited for the new setup. It's ideally suited. I do a calculation based on the size in microns or micrometers or micrometers, right, of the pixels, and the size of the pixels on this is 4.63 microns. Okay, and the size on the new camera we're going to use for this is actually 2.4 microns. It's literally half the size in pixels. So that means that we'll have double the resolution with our new camera than we have here. In other words, when I zoom in, okay, let's just show you. If I zoom in on, say, Measure 4, okay, you can see Measure 4. It looks okay, but it actually has stars that don't look as sharp as they could, and that's because the camera, as good as it is, the camera is not quite the best. Oh, this is a beautiful shot. It's not quite the best camera to use here. So if we literally double the resolution, then every star in here is going to be a lot sharper. So we're looking forward to that. We don't have a problem with guiding. Obviously, guiding's going great, you know. But this camera that we're using on the new system that already has more focal length would be ideally suited. But we're going to get another one still anyway, probably called the 533. There's pixels are square. Okay, these pixels we're using are kind of elongated or rectangular. So I think that's interesting. But we'll do what we can. Meanwhile, look at this picture now. This is Antares, a very, very large supergiant. If you put that where the sun is, it would go all the way to Jupiter's orbit. Okay, and that's just the radius. Remember, it goes the other side too, so it covers the whole orbit of Jupiter, just about. Okay, so that's a big star. You know, it's bloated, and it's in that asymptotic giant branch, the second coming, so to speak, of red giantness for stars. That's where it is. And it'll be supernova candidate sooner than later. It may already have gone supernova, and we won't know it until the light train gets here with that information in it. But look at the Antares Nebula around here. This is beautiful. Now, Antares itself is not a star that's spherical. I mean, we think of stars as round balls of hot gas. We're always taught that. However, we've discovered that these red giants, supergiants in particular, actually have explosive eruptions on their surface that push out the outer reaches and make them look much less regular. So they're all lumpy. They're bumpy and lumpy on the outside. The bumps can be huge, the bumps can be small. In the case of Betelgeuse, it's one such lump that got away and splashed off the star that began to cool and form dust that actually is possibly responsible for why Betelgeuse dimmed so dramatically a couple of years ago. Cosmic Ray, sorry Daryl, 1 second. You're asking why mirror flop's not a problem on this scope. I mentioned why, but you didn't hear it. It's not a problem on this scope because of the fact that we're actually so wide field. If we weren't wide field, it'd be a huge problem. All right, so wide field scopes don't have that problem. And in large observatories where there's multi-million-dollar telescopes using lenses and mirrors like this, they countered that problem with guide scopes years back. But those are always manned observatories, and if they there's a process to probably lock the mirror for each shot automatically through the computer setup and whatever. Technically, I could engineer a way to lock the mirror before every exposure and make it impossible to try and focus if the mirror is locked. So you can't do that. You know, you can't focus if the mirror is locked. You gotta unlock the mirror first, and just make it an idiot-proof thing where it would automatically unlock the mirror if I want to call for a focus. So I could do that. I could engineer that. Yeah, go ahead. Sorry.
As James mentioned, you can always put another focuser on the back of the telescope, Crayford or such, and go ahead and lock the mirror down.
Yeah, I guess so, but I could actually put a. Yeah, I could, because we're actually using a different mount. We're not using a fork mount like this one. If you look right there, you see the fork mount. Okay, we're not using the fork mount on the new one. The new one's going to actually be a German equatorial, so we won't have the problem of stuff trying to pass through the bottom like this one would. This will. We have everything. Right now, what's on the back of the scope is nothing. Okay, there's just a counterweight back there. Right there, that little round thing you see right there, that's the camera. You know, and then the telescope optics are behind it, and that's why we see the halos the way we do with these lines, because we have cables coming off of that. It never set well with me how you could do that. I never set well with me, but it makes sense, and now I'm willing to do it and so forth. But I never was. It always seemed odd to me.
Is mirror flop, does that come from the meridian flip thing?
It can with a German equatorial, yes.
I think that's one thing Celestron boasts about on their bigger mounts is they've dealt with meridian flip.
Yeah, we're getting a CGX mount for ours. I still have some questions about that, okay? And I'm willing to do off-axis guiding with a guider because then what you see is what you get. You don't have to worry about two telescopes cooling differently from each other and changing slightly in their positions as cooling occurs. In this particular case, that's still a problem for us, but it's such a wide-angle field that it's not noticeable in the images.
Yeah.
Like, again, we're 4 full moons across and 3 full moons tall. So we have a lot of forgiveness going on with this system.
Mark, by the way, I took Izabela's mosaic and put it in your chat.
Oh, okay.
But you're still working on the mosaic right now, aren't you?
Yeah, I mean, this is the Antares side of it, and Alniyat is up off here somewhere out here.
So I mean, I assume what Izabela did is the first 2 images out of 4 in a intended mosaic.
Yeah.
Okay. Well, Izabela, you get to play with the mosaic even more.
Yeah. Oh, I see. Okay, let me bring that up here, maximize it. Actually, let me
cool picture.
It is a cool picture, yeah. Neat. Okay, let's see if this is going to help us here. No, not yet. Just a minute. I figured it out. Okay, that's what I gotta do is just... This is what I want right here. Okay. All right, 1 second, guys. Let me just get the let me get the screen up here. Okay, 1 second. I'm gonna have it ready in just a sec. Okay, should be coming up here in just a second. Alright, well, it's not. Oh, yeah, it will. Sorry. Here it is. Okay. Well, there you go. That's what it looks like.
I don't see it.
No, you don't.
Okay, be that way.
You're not allowed. No,
Yeah, I'm looking
I
at it on the YouTube page now.
yeah, I shared the window, remember, with you. So
Right.
you, for the benefit of having a nice big window, you don't get to see the other things which look like black squares.
Okay.
Okay.
Alrighty, I see it on the YouTube.
All right, so there you go, folks. That is that guy, and that will be made available to you as well if you want to check that out. I think you would. All right, now let's go back to here now. Okay, so this is cool. Notice all the tremendous. I mean, by faces glowing orange from Antares there. It's like so bright. Okay, but it's pretty cool. Yeah, this will all be part of a mosaic, Izabela. She asked if it was going to be. She didn't realize. But look at the details in this amazing nebula here. And there's more to the left, which I won't do. I want to go see what else we got up there. There might be some more interesting things to look at right now. Yeah, there we go. Okay. Okay, so I'm going to... I'll save this one more time. So we have an even 30. Alright. And I'll save it exactly as seen.
You know, one other thing with the C11, if you ever get adventurous, you could always try running it at f10. Get some really, you know,
Yeah, but then
images.
I agree with that, and they'd have to be pretty bright, because remember we're doing the astronomy for the masses kind of thing, so I want to show people things.
I know.
I mean, I'd love to do that, but to get like the heart of the Alniyat Nebula or the heart of the Pho Ophiuchi Nebula, we would be actually taking like hours of exposure at f10 to get that. Maybe partial hours of exposure.
I understand.
Yeah, and so it's a tough decision. But
I'm looking in the crystal ball though, and I bet you someday you're gonna shoot that thing at f10.
Yeah, I'm pretty sure you're right.
Of course, if you're in Connecticut, you have to get somebody to go out there and swap everything around for you.
Well, maybe. I'd like to see if there is a rotator that'll get the F7 the F7 reducer and rotate it out into an open space so it can actually just do the do that natural F10.
Oh,
In other words, maybe automatically shift. The back focus is the issue. That's all.
I don't think it will. The F7 reducer has like 3¼ inch threads or something that screws directly under the rear cell of the telescope.
Yeah, that's my point. It needs some kind of a rotator to rotate it out and see if it'll work that way. I don't think it'll... I'm not going to go through that, although I was thinking of doing the rotator for the off-axis guider, and it turns out they had one, so I didn't have to. There's one out there that we're going to get with it. That's like almost $700 just for that rotator.
Oh.
But, I have to do what's right for everybody wants to watch.
Oh, yeah. I understand. Hey, can we zoom in on N4 before we move on?
Yeah, I was just about to move on here. Yeah, but let's just do that. All right, let's bring back some of the detail in the core.
Michael seems to be having a religious experience with M4 there.
Well, you can't blame him because look at that. It looks like it's got this vertical line of stars. That's just the way it is.
That's too cool. M4 has always
really
been
pretty.
one of my favorites.
Yeah. And the guiding is really nice.
One of the first things I ever looked at, too.
Yeah. Oh, James, yeah, we're gonna get the C11. I actually there was an auction and I wanted to bid on a Meade 16, but then I started to think about it and I realized it might work good for maybe 6 months, and then when something goes wrong, where do you get the spare parts? And the answer is you don't. There's not a lot of spare parts out there. So unfortunately, I had to let it go. And I had an opportunity to bid on a C11 astrograph as well, which was going to be F2. But I let that go too. And the reason I did is because I wanted to make sure that the second telescope is very different from this one that we're on right now. This one is a wide field scope. And with the new camera, we're going to be able to zoom in tightly. But the next one's going to be a high focal length scope that's going to allow us to see things natively much closer, like the pillars of creation in Measure 16. We're not going to see the entire thing. We're going to see just the pillars and a little bit around them. And that is, to me, that's the trade-off. And then for you, at your end, what you're going to see is you're going to see the wide-angle view. And in the same session, you're going to see the much closer view as well. We'll be swapping images. You'll be swapping the systems back and forth. You'll see them. You'll see them appearing, and it's going to be pretty cool to see all that.
Can you back out a little now?
Well, Michael Hedrick's not done with his religious experience. Yeah, okay.
Okay. I wanted to, Michael, there's actually two globulars in the image there.
Well, that one there, yeah.
Yep. See that third object up there in the middle distance, far distance.
Okay, so let's move this down. You see how just by setting the black level, it sets apart some of that red dust. And once we get there, it stabilizes and the image comes back fully clearly. Look what we see. All these beautiful rays and so forth. Very cool. All right. All right, well, this is cool. So now we're going to get out of this. It's been saved several times. And we're going to go back to our night vision mode.
When we look at M4, that's the closest globular cluster to Earth.
And look at this. That line is really pronounced when you see it this way. That apparent line, I should say. All right.
A column of bright stars.
Yes, it is a column of bright stars. Now, let's... it's also called the Crab Globular Cluster, and I don't know why. It's only 7,000 light years away, apparently.
Yeah.
All right. And you'll notice from our field here, we are past the meridian. And we could actually... Well, okay, let me go see if we've got... Oh, we got the dark horse now, and that's going to be perfect if we want to see it. And we have the lagoon and the Trifid. Let's do the Trifid tonight. I want to do the Trifid. I like the Trifid. I like Trifid.
Could you maybe fit M6 and M7 in the same field of view? They're a little down to the south. On the way to the Trifid.
I guess.
They're two star clusters.
Yeah, I'm trying to find them.
They're above the tail of the scorpion.
I have to find out how well I can... let me just see what their elevation is. That's where they'll... Ptolemy's cluster or the butterfly cluster?
Uh, Ptolemy is one, Butterfly is the other one. M6 and M7, I forget which is which. I want to say Butterfly is M7, but I could be wrong. I thought I was wrong once,
Okay.
but I was mistaken.
Okay. Oh, we could try the Lobster Nebula. I've tried this before, and I was able to get some of it. But it's as high as it's going to get. So, can we try this first?
Sure.
All right. It may not work because, again, we do have the walls of the telescope or the building to worry about. But we'll see. Let's go see. Oh, by golly, we might get it. We might get it. Very, very rich area here. You can see there's red here. Okay, we're going to try this. This might be a beautiful cluster. Nebula. Let's just do this. I think we're above the wall. This is good. Oh, I'm excited now. Very exciting. Day of the Trifids, that's right. Remember that?
Oh, yeah. That scared the daylights out of me when I was a kid.
Yeah, I couldn't understand how they were killing anything. I didn't get it.
Oh, I had nightmares about like
Really?
vines or whatever, shooting out and grabbing me around the ankles.
Yeah. I don't blame you. Okay, we're going to go and move it more in because I see the nebula right here. And I see another piece of it up there, so I got to... This is as far as I'm going to go. Ooh, there's a nice dark nebula right here. Look at that. You can even see it.
Huh.
This is an extensive nebula, so we're just going to get a piece of it. And we're above the wall, so this is good. Let's go check where we're aiming right now. Oh, did I go to the wrong place? I went to the wrong place. How about that? We're in I don't know how come that happened.
What were you looking for?
The Lobster Nebula, but it didn't actually go to the Lobster. It went south of something else, and I saw the red, and I didn't realize it looks very much like where the Lobster looks, like this. See?
Oh.
So now I wondered why it looks a little strange. I was like, something's not quite right there. What's going on? But I figured it out now. So let's.
So not a wrong coordinates then.
It wasn't a wrong coordinates thing. No, we have had that before, as you know.
Yes.
Okay, so. But we're good, actually. We're above the wall, and let's check out the elevation that we're actually sitting at right here. We're at 22 degrees above the horizon. So we have our southern exposure limitation is 22 degrees. Okay. There we go. Guiding is beginning. I'm going to do a 25-second shot of this. And then we're going to go into our stack. This is a beautiful nebula. I've only imaged it once before. In all of our time, only once before. And it was really pretty, but I never did it again because you had to get it just at the time where it was peaking above the horizon. Above the horizon enough so that we could see it. The timing was never good. Look at that.
Wow.
Isn't that pretty? And we got it now. We're going to be lobster nebulaing tonight. Let's see if we can get rid of some of the blue. There we go. Again, notice our noise, okay, level. It's going to change. And for Cosmic Ray, sorry, I'll get to the Veil Nebula in no time. And this is the Lobster Nebula, guys. Hello, Mr. Django. How are you doing from Belgium, if I don't miss my guess? Very nice.
That's trippy looking.
It's gorgeous. And it's somewhat low to our horizon here. But it's really pretty. Let's just pull it right to there. Wow. That's nice. Excellent, Mr. Django. Yeah, Lobster Claw is down below the Bubble Nebula, isn't it, Izabela?
Yeah, that was your question.
Yeah, I think that's below the Bubble Nebula.
I remember the Lobster Claw. That's up in Cygnus, Cepheus?
Cepheus.
Yeah, I thought so. I remember you imaged that last year.
Yeah, yeah. See, as we add exposures, this gets crisper and cleaner. We're at 6 right now.
That's too cool.
This is a nice one. This is again new for us. I've only imaged this one at a time. Yeah, only one at a time.
When you get a few images saved up, hopefully we can zoom in on it some. I'd be interested to see that brightest portion up there at the upper right.
Yeah, I'm wondering if there's some young Herbig-Haro objects in there. Are you ever looked that up to see if the Lobster Nebula has any Herbig-Haros?
Yeah.
Because if so, they're going to be right there. That's what it looks like right there. The spot we're talking about is this right here, guys. I'll point it out. Right there inside our box. Hope you guys like the fact that we can draw on the image so you can see things. That's a capability I added. I thought we really could use. Let's zoom in a little already. Look at the gossamer details here.
The nebula contains many protostars shielded by dark disks of gas.
Okay, those are Herbig-Haros.
And young stars wrapped in expanding cocoons or expanding gases surrounding these small stars.
Very cool.
NGC 6357. Also called the War and Peace Nebula by the mid-course space experiment scientists because of its appearance.
Hmm.
In infrared light, western part looks like a dove, while the eastern part looks like a skull. So, war and peace, I guess.
I guess. Wow, this is pretty interesting. Now, if we remove the color, this is okay. That's how it would look to us. You see how the color actually totally enhances our view and shows us a lot more of what's going on in there. So this is really a good color level right here. Look at the gossamer strands up there. That's beautiful.
There are several open clusters in the nebula, massive stars.
Okay.
One of the most prominent sites of massive star formation in our neighborhood of the galaxy. A variety of early O-type stars resides in this nebula,
Wow.
blowing bubbles around the star clusters that can be seen in the molecular cloud.
That's very cool.
And there's some really trippy images at the wiki page. One is a Hubble image, the other one is an image by the Dark Energy camera.
Okay.
And they're both as trippy as could be. I'll post a link.
All right, let's try to darken a little bit of the background to show a little more detail. That should be good. Trippy images, man.
Yeah, man.
Oh, wow, man. Trippy images, man. Tommy Chong, you know.
Oh, yeah. Dave's not here.
Dave's not here, man. Look at that. That's really coming out. That's really pretty.
Can you zoom in
Right.
on that a little now?
Yeah, I think so. Let's just try this section up here.
Yeah.
Oh, looks like I got to focus. Well, it's actually okay. That's okay. It could be a little better. Wow, that's
that
pretty cool,
would
though.
be a good target for the C11.
Oh, you betcha. Because it would fill this field. Yeah.
That's really something.
Mm. All right, let's back out and see the entire extent. That's really pretty.
Some ways it kind of reminds me of the rosette when you back out. You can see the
Yeah.
loop going all the way around it up at the top.
Yeah. I guess if crab wasn't taken, I would call this the Crab Nebula. It certainly looks like a crab. Michael, now that's a religious experience. Yeah. Well, there's 20 shots of the Lobster Nebula. We're gonna go to 21 and clear it. And what were the clusters you wanted to see?
M6, M7. We can do that another time.
Okay.
Go do the Trifid or whatever you wanted.
Yeah, I'm gonna go to Trifid now, and we'll do a refocusing. This is beautiful, though. This is really pretty. All right.
David Schmidt has a question for you.
Yeah, David, what do you have to say?
He has a question about the colors.
Okay. Can you read it to me while I'm doing this? I'm just trying to...
Yes. Does
Sorry.
a color that is sort of a mix indicate a mix of elements, or is it more a function of distance? Example, the Lobster Nebula is not really red. It's like a reddish orange.
Okay. The reddish color, David, is due to the ionized hydrogen gas. That's the transition that we most often see with hydrogen. With the electrons that are in the atom bouncing off ionized wise and then bouncing back in. That's something that often happens. But the color doesn't depend on the distance per se, right? The color is actually related to the element that's being ionized, and that's pretty much it.
Well, it also depends on where your settings are and the color balance.
Yes.
I've noticed some images you've done in the past, they have a distinctly orange hue to them.
Yes. Okay, I'm going to do a refocus here. There we go.
Turn your T-comp on while you're at it.
Actually, I've decided to run without T-comp for much of the photos, and the reason is because the temperature compensation I found is reliable, but not reliable. And it can change the focus incorrectly sometimes and ruin a shot.
Okay.
Right in the middle of it, and I don't even know it.
Yeah.
So if the temperature stays relatively the same, and it doesn't vary by like more than 5 degrees, that's when temperature compensation matters.
Yeah.
But
I see
here, go ahead.
your temperature in the dome is still 35 centigrade.
Yeah, 35.13, and it was 36. So that temperature won't make a big difference.
Okay.
Thank you, Cosmic Ray, for that article on the color info. All right, so this is going to be the Trifid Nebula. You'll see a beautiful blue nebula up here, and you'll see this beautiful red nebula down here. We've got our focus position, and it's going to be ready to focus in just, well, one more thing. There it is. So now you'll see it come back into focus, go out of focus as it travels all the way across the whole run, then come back in and focus at the best point. And it's the interpreted point. So it's not a position that's it's not a position that's an absolute. It's actually a mathematically determined point. And so now I imagine that we're going to be working on this right now. I'm going to take us up, and we're going to do a 28-second shot here once we start guiding. Okay, we're guiding now. There we go. The Trifid Nebula, so named because it has 3 major lobes. Okay, I can't wait to process that. Oh man,
Yeah, that's a cool picture.
It is. The Trifid has 3 main lobes, and it's an emission nebula of hydrogen gas in basically a ball around the hot stars. And then there's a reflection nebula above it, a blue nebula there it is right there, which is actually, let's just add some more dynamic range here. There we go. Ah, look at that. Wow. That's only the first exposure. It's going to be beautiful. All right. And this blue reflection nebula is a dust that's scattering starlight from this star here and other stars out of view. And you'll see the blue tends to ring this. And that's what's interesting. The blue tends to ring it. So the nebula actually is a small emission nebula surrounded by a much larger blue reflection nebula. And the blue, there's no reason to think it doesn't come forward of the nebula here, but it's overwhelmed by the brightness here. And then you have these sinuous dark lanes of dust which make their way through the nebula as well. Naturally, looking around, you can see that we're in a very rich area of the Milky Way with lots and lots and lots of other star clouds and emission nebulae called diffuse nebulae here. But this is our amazing Trifid Nebula. Also known as Messier 20.
I've noticed tonight, I see it now with the Trifid and earlier with one or more of the images you were doing. I see a sort of a slow pulsation in brightness.
What do you mean?
A very subtle change in the brightness of the Trifid.
Oh, I mean while we're exposing?
Yes, it just did it. It pulsed brighter.
Okay.
And it just did it again.
But that's because I just did the unsharp mask, and if I turn it off, you'll see it'll drop down. See, there it goes.
Okay.
So if I add the unsharp mask, it's going to add some detail in here, which I want to see in these dark lanes out here.
Yeah.
And then I'm going to pull the color back actually a little bit.
But I still see the pulsation.
Yeah.
It's kind of a slow pulse.
Mm-hmm.
Maybe that's...
that could be due to the remote computer connection operation.
Or maybe it's exposure.
Yeah, maybe at the conclusion of each exposure, you see the new data added in, and that's going to change the color slightly.
That might be it. I haven't timed it.
Yeah. Okay, there's 8 exposures right there. Look how pretty. We're going to zoom in on this because you're going to be able to see some neat detail in here.
Ray had another question or two for you.
Okay.
He was asking about how you're presently focusing, and I answered assuming you're just focusing by adjusting the primary mirror, correct?
Yeah, the primary mirror moves in and out. And we're using a focuser called the microtouch focuser. It's a stepper. Go ahead.
That was his next question, was which one, and you said it's the microtouch.
Yeah, and it's a stepper motor, which stepper motors are great because they have discrete steps. All right, let's say there's 2,000. Actually, this stepper motor I think is like 50,000 steps, and each step is a direct increment. And if you go down 10 steps and back 10 steps, you actually come to the exact same spot. So focusing then is much easier and far more of a delight. We actually are auto-focusing using the microtouch focuser. If we had a manual focuser, this would never work. In other words, there was an old Meade focuser that we used where it just ran a little motor which made the mirror move in and out. Okay, and that was crude at best, and it was great because we had it when we had it, but it was crude. And now we actually have the ability to go 50,000 steps one way or the other to try and get what we want. Hey there, Gladys. How are you?
I understand your question.
I didn't either. Hi, Gladys. Good to see you. Well, 12 images, and already the Trifid is almost noise-free. Look at all this detail up here, guys. Let's see if we can extract some more detail. Look at that. Again, all that dust that we see, those are that dust is literally the foundational elements of life within all that. Look at that. Now I'm going to back out a bit. I want to actually do one other thing. All right, there we go. That's good. I'm now going to use this histogram, it's called, to see what's really hiding back there. Let's pump it really hard. And now you can see that there's even more stuff out here, which even extends into here. Now we can actually keep that. All right. And
so I see 4 lobes. Why do they call it the Trifid?
I know, right? We got 1, 2, 3, 4. It's possible that that fourth lobe developed over the last, couple hundred years. I actually have an image of the Trifid, which that actually kind of looks pretty odd. Look at that, guys. It's a glowing blue ball punctuated by an emission nebula associated with it. Now, we don't know if that emission nebula is up here and that blue ball is more back here. Most likely they're associated with each other in space. They might be more elongated, more lengthwise. So it's hard to know.
You might have said earlier, and I missed it. I assume the blue is the Rayleigh scattering.
Yeah, the blue is, again, the scattering by the dust. Remember, this dark dust here, the reason it looks dark is because it's not very, very thin as in out here, so it looks denser. But it's trying to scatter too, and scattering's going on throughout all this. And you'll see some really, really beautiful locations, for instance, where the dense dust trails off, and you can start to see kind of around the corner as it starts to do the scattering. You see like a bluish fringe around it. It really is stunning. In particular, in the Chinese Dragon Nebula, we see that fairly often. This is something. Wow. If we take down our other histogram, okay, that's what we're looking at. We add it back, and this coming up, that's what's really there. For purposes of doing our shot, I'm going to take it down. And I'll add it back by doing a stretch. You move these closer together. Okay. There we go. Okay, there we are.
Mark, is it too late tonight to look at M101?
I hope not. I imaged it the other night, and it's definitely orange. Definitely orange.
About supernova.
Yeah, I wanted to see the supernova. I meant to do it as we got started, but I just got too excited about the possibilities of the Milky Way.
Well,
we're at 22 here, so we can save this right now as a Trifid Nebula.
There's tremendous star fields in that picture.
It is just beautiful.
Yeah. No. Looking in the general direction of the center of the galaxy, it's down to the lower right from this image, but still.
Yeah. We'll tell you what, we're going to go look at M101 now and then come back to this, because, not Trifid in particular, but... All right. Okay. So. We're going to be way over into the northwest.
Yeah.
But we'll go. Let's go check it out. We still can see it from here.
Good thing it's so high up.
Yeah.
So
watch
far
the telescope's going to lean way out over there now. It's going to be looking way out over there. Okay, so you can see the telescope moving right here. Okay, you see it moving there. Heading back over, and we'll see the nebula. I'm sorry, the galaxy in just a second. Here it is. Let me get rid of our words there.
I see the supernova now.
Yep.
It still stands out.
Down. It does.
No, Gladys, it's another galaxy.
Yes.
It's that supernova we've been watching for, a couple of months now, I guess.
Yeah. It used to be bright blue.
May 20th, I guess.
Yeah. We have a record of it in all of our imagery. It was bright blue when it first occurred. And then it ended up becoming less high temperature, started to cool, and now we're gonna notice it's a little bit red now, because I checked on it the other night. Here we go. Let's get out of here, go into our stack. We'll take our Trifid out of there. Look at that beautiful. Jeez, gotta love the Milky Way, guys. Okay, that's up there. We'll clear it now and see our first noisy image. All right, let's do that and process it. There we go. And right away, we can come in and look, and you'll see that the supernova is no longer blue. It's actually got it's orangey. It's dropping in temperature. So
it is.
The supernova is now actually losing its luster.
I think it's noticeably dimmer now, too.
Yeah, it is. Ray, Microtouch is a Star Zona product, yes. Actually, for the C11 though, I don't think we're gonna get the Microtouch. We're gonna get the ZWO focuser. But it's fine. I can integrate anything to anything, so I'm okay. We'll make it happen.
You remember Jim's Mobile Industry? JMI?
I sure do. JMI.
Yeah, he was a TV repairman, and he invented the motofocus. It was the first, or one of the first, motorized telescope focusers. That's what got him started into, got him out of television repair.
Oh, wow.
Somebody asked earlier, I don't remember who, about like a custom telescope accessories maker for, like, you know, putting together all the components you're planning on, stuff like that.
Okay.
Paul Van Slyke is his name. VANSLYKE.
I
Paul
heard of
Van
him.
Slyke. He lives in Black Forest, just north of Colorado Springs here.
Okay.
He was a maker of very fancy and very expensive heavy-duty telescope accessories, like what maybe this person is thinking of.
Okay.
He used to have a 40-inch telescope that he built himself. It was a public observatory. Well, he had had programs out there for the public, and he built some really amazing stuff. He got burned out during the Black Forest fire here 10 years ago, 2013, and I don't know if he ever went back into business. He had a full machine shop. He was building some of the fanciest, like big, huge turret, eyepiece turrets, and all sorts of fancy guiding equipment, all sorts of stuff. Yeah. I don't know if he's in business anymore.
I don't know.
I'd have to look for that. Yeah, he sold the telescope to college down in Pueblo, Colorado. But he still had his business going, and then he got burned out by the Black Forest fire.
Okay.
They still list his phone number. Van
maybe
Slyke
he...
Instruments. Here it is, Van Slyke Instruments.
Look at this. This is really pretty.
It is noticeably red, too.
Yeah, it definitely is. Wonder how long it'll be before the James Webb can pick up some nebulous outflow.
Maybe
Might
it
be
already
a
has.
couple years. Maybe it might take a couple years.
Oh, well, yeah. Somebody asked the other night, how come we're not seeing so many of the web images? I know that's been a pet peeve of Izabela's. People are sitting on web results. It's because they're...
it's their research. They've got to have first dibs at it.
They get first dibs, and if they haven't written the papers yet, I guess we don't get to see it.
Gladys says, Mark, you should make a game with your images. It's just a random suggestion. Actually, in our Etsy store, I'm thinking about offering puzzles with our images. I can make puzzles up to 1,000 or 5,000 piece or 1,000 piece puzzles. So that'd be kind of cool. Boy, that's gonna be hard as heck, though.
Michael asked me a question. Do gravity waves ever travel slower than the speed of light? That's been maybe a debate in the past, Michael. Gravity works at the speed of light. If you differentiate between the waves, like the waves that propagate when, like the LIGO telescope sees two black holes collide or whatever, the period of those waves, this gets into the big deal they announced a couple of weeks ago about using pulsars for timing gravitational wave events, and this gets into the whole gravitational background noise they talk about now. The periods on some of those waves were like decades long.
Oh, yeah.
Does that mean they don't move at the speed of light? Gravity itself moves at the speed of light. I mean, if it's just like if the sun went out tomorrow, we wouldn't know it for 8 minutes. It takes that long for the light to get here. And if they took the sun away completely, we wouldn't know that either until it disappeared 8 minutes later. The speed of light, the speed of gravity, sometimes they call it the speed of causality. How fast things happen, how fast we see things happen. It happens at the speed of light. As far as particular waves from gravitational events, that becomes an interesting question, because this whole deal with the pulsars, as I understand it, they're seeing very long wavelengths, very low frequency waves in effect. They're detecting these waves at different pulsars at different times, as I understand it, which kind of blows my mind. But how do they know they're seeing the same waves from different pulsars at different times, and how are they keeping it straight? Which one belongs to what?
Yeah.
Can you expand on that, Mark?
Well, I'm gonna pick up kind of where you left off a little bit, but in terms of what you said before is correct, right? Gravity moves at the speed of light. As far as it moving any slower than the speed of light, we know, for instance, that light is slower in different mediums, right? Light, we always have to specify light in a vacuum, is 186,282 miles per second, right?
Sure.
We have to, but we don't. But if it goes through water, then it's a little bit slower. If it goes through a substance where it's refracting, then it's going to move a little bit slower. So the question is, do gravitational waves slow down in the presence of interstellar gas, especially over very, very long distances? What's happening there? And where this might be interesting to draw a parallel with is with fast radio bursts. FRBs, these fast radio bursts, we look at their dispersion. We look at how they're stretched out by the distance they've traveled to determine factors that include what they've passed through. And through the study of the dispersion of these fast radio bursts, we found that there's these large clouds of gas out in between galaxies that we never knew were there, that they're passing through. So that's the only thing I'll add to this, basically, is saying that gravitational waves, like light waves, may slow down depending on the medium they pass through. So that's something we don't actually know yet.
I hope I answered your question, Michael. If I didn't just confuse you worse.
All right, let me try something here. Okay, the elephant's trunk is quite high. We can check it out right now. But there's something else near the elephant's trunk that Izabela would like to see, and I think that's the Garnet Star. Isn't that Herschel's Garnet Star is here?
I believe so. Is that a carbon star? I forget. Must be.
I believe it is.
There's Herschel's Garnet Star. There's Hind's Crimson Star.
Mm-hmm.
And Mira, as I mentioned earlier tonight, though, if I remember correctly, Mira is not a carbon star, but other Mira-type stars can be carbon stars.
Yeah. Okay, it's not in there by that name, but it's it's up here. Let me go find it. Okay, we zoom in. There it is, right there. Bam. The Garnet Star. Okay, that's Arrakis. All right, here we go. We're going to go there, and this is for Izabela, who is into carbon stars, and I believe this is one of them. It's in Cephas. Okay, and we're zinging right around here. And you'll see it come in. There it is. Can't miss that orange. Yep, really pretty. And while we're here, we'll image the elephant's trunk. Why not? Okay, so let's go to the west a little bit. Incidentally, part of the reason that we have to redo the focus after moving the telescope this far, like this, is because of mirror flop. That's one of the reasons we have to refocus. Because we're actually forcing the mirror flop.
I found an interesting page on the story of Black Forest Observatory. I sent it to our private chat.
Okay.
Take a look at that when you get a chance.
All right. So what we're going to do is we're going to just do a 12-second shot of Herschel's Garnet Star here. And I'm not even waiting for it to... not even waiting for it to find a guide star. Because I think it'll be like that. As you can see, it's almost an unearthly shade, isn't it? And you'll notice this stuff that is around it. This is actually not associated with it. It's actually a nebula that's part of this other one we'll be looking at here, as you can see now the extent. Okay. Beautiful, beautiful group of objects. Look at in here. You can already see almost a three-dimensionality in here. Really cool. And I'll make this official. I'll just say it is the Garnet Star. Why not?
Mu Cephei.
Mu Cephei, yep. There's one of Daryl's star trains. Okay. 7 exposures is good for this. Alright. We'll save that and save it exactly as seen. Wow. So yeah, and that's an example of a carbon star, I believe.
I'm looking right now.
It's an M21A supergiant, I think. Okay.
It is.
You asking me?
No,
Are you agreeing?
I'm saying
Oh,
you're
okay.
right. It's an M21A. Since 1943, the spectrum of this star has served as a standard by which other stars are classified. Interesting. Herschel discovered it, of course. William Herschel described it as a very fine, deep garnet color, and he compares it to Mira, Omicron Ceti. And Herschel's Garnet Star is a variable star. Blah, blah, blah.
Okay.
Very luminous red supergiant. Are you even there anymore?
No, I moved off it.
Okay.
That's all right. I want to position us in the elephant's trunk here. Here we go.
Mu Cephei is nearing death. It's a good supernova candidate. Fusing helium into carbon.
Yep. Asymptotic giant branch star. If I don't miss my guess. No, actually, if it's fusing helium into carbon, it's going to end up making its way up the asymptotic giant branch after the helium runs out. Okay, let's do this. Okay. And let's do a 25-second shot here. Show everybody what's going on here.
Oh. Quick look, I don't see anything about whether it's a carbon star.
Okay. It might not be a carbon star as I think about it, but let me fix that right here. Oh,
Mark, will you
look at that.
excuse me for a moment, please?
Sure.
Be right back.
Okay. All right, let's bring out some details, shall we? And away we go. Look at that. That is beautiful. This is the Elephant's Trunk Nebula right here that you're seeing, and this little area is like called the caravan. Little camel humps. Beautiful molecular clouds of dust out here with gas as well. Elephant's Trunk is a fertile location for starbirth and potential planetary birth, and possibly in the distant future life. Let's zoom in on this section here. I want to show you something in here. Okay, we get in here, and we're now, this is this little Elephant's Trunk extension of Dark Nebula. But look inside. There are these two stars in here. And those two stars are illuminating and clearing this interior with their stellar winds. And they're pushing out, and they've made a hole because they're pushing stuff away with their stellar winds. Isn't that cool? And that's what this is doing right there. I'll zoom out a little so you can see it better. Okay, and then I'm going to help you see it even more clearly by giving us some contrast in the background. There you go. Look at that. You look at this, you say, I don't know where the nebula begins and where the stars begin. I mean, it is just stunning. Gladys says I'm going to be Mrs. Frizzle. Come along on the magic school bus. It's kind of funny. Welcome back, Daryl.
Thank you. One last thing about Herschel's Garnet Star, where they said it is a prime supernova candidate. It's a huge red supergiant.
Yeah.
It is 3,000 light years away, compared to 600 or 700 for Betelgeuse and 600 or so for Antares. So I imagine 3,000 light years, that'd still be enough to make a really good show.
Oh, I bet.
Right. The progenitor for the Crab Nebula, that's what, 7,000 light years away? 5,000 light years away?
Yeah. It was seen in the daytime.
Yeah. So it would still make a heck of a show if it blows up.
Yeah.
When it blows up.
This is incredible. I was pointing out when you were gone how this hole here opened up because these stars, stellar winds, are literally pushing dust and gas out of that region. And that's what happens with hot stars. They'll actually form cavities around them, clusters especially, form cavities.
Well, that's what happened with the rosette, isn't it?
Mm-hmm. I have to say, Izabela mentioned this before. The telescope seems to be performing better and better than ever.
Mm-hmm.
I mean, we're seeing detail that's been kind of hard to see in the past. Look at this beautiful nebula here. Let's go out to 33%. So that's our whole field right now. That's something else. Wow. I hope you guys are having a good time tonight. I really find it interesting. I knew that I was going to just be going and going tonight. I just knew it. You know, I don't know any better. If you guys are out there just lurking, some of you that haven't subscribed yet, please subscribe. Because we're just a few subscribers away from 8,000 subscribers. Looking forward to that. Kind of cool. Great. Man, this is just something else. I'm going to zoom in on that section again now that it's got a little bit more. The new camera is going to show this region so much cleaner. It looks a little fuzzy. The new one's going to show this without all this fuzz. It's going to be sharp and clear. Look at that. You can see this knotty area here. And then you can literally see these stars in here basically forming a cavity in here. And here's what we talked about before, the caravan. That's this little lumpy section here. Looks like camel humps. That's why it's getting the name.
One hump or two. What do you call it if it's a two-hump camel?
Dromedary.
That's a one-hump camel.
You sure about that?
Yes, I am.
Is that your final answer?
A two-hump camel is a Bactrian camel. Bactrian, Bactrian.
Yes.
That's the ones they have in the Gobi Desert.
Okay. We're going to save this. This is the first view of the elephant's trunk in a year.
Time flies.
I know. All right. Well, we saved it. And now we're going to head to something that's even equally as exciting.
Cygnus, the Veil Nebula.
Yay, there we go. Just for cosmic ray. Let's see here.
Lots of cool stuff up in this part of the sky.
And there is actually. We've got the
There's the wizard.
Yeah, I know, but we also have the iris up here, which is a beautiful.
Iris.
Yeah, the iris is gorgeous. Let's go do a few exposures of the iris.
Then the wizard.
No, I don't think we're gonna do the wizard tonight. The wizard's a little slow, a little low. We're actually
right.
we're pushing the limits right now.
Yeah. Okay.
All right, so now we're gonna just
Telescope performing so well, I'd be curious to see the little girl and the wizard.
let me go out to 33% so we can frame this right. Holy cow. Good thing I did.
Michael, the Perseids are next month.
Yep.
They're usually around the 12th to the 13th of August.
I'm going to be in southern Texas at that time.
Oh, yeah?
Yeah, I got to do a conference down there. The Edinburgh UFO Festival. They want to move forward with it. They asked me to talk, so I will. Very cool. I'm going to move this over because I know there's a beautiful nebula over here. I don't want to lose.
When are you going to the Ozarks?
That's April. They invited me back too.
Oh.
Yeah. I told them I would love to talk there again when they said it. So I'm gonna. All right.
That's the Arkansas Ozarks.
Yeah.
I was born and raised in the Missouri Ozarks.
Oh yeah, there's a bunch of different Ozarks, aren't there?
Well, it's all the same Ozarks, actually. It's just which side of the state line you're on.
Okay.
Southern Missouri, northern Arkansas.
Here. Roger that. Oh, look at that. No. Oh, I shouldn't have done that. I saved that to the wrong thing. No problem. All right. I'll move that. I'll move it later.
Michael, the Perseids have a pretty broad peak, too. The peak night is around the 12th of August, or the 13th. But they build up for weeks beforehand, and then they trail off for weeks beforehand, too.
All right, so while this is working, let's go see what else we want to see tonight. I want to see everything, but I can't. I actually have to get up tomorrow.
Yeah, it's about pumpkin time for me, I'm afraid.
Okay.
We're still
if
famous.
You guys, yeah, that's it, and the dumbbell nebula and everything. If you guys are, if you're on Facebook, go check out my post in SkyTour live stream Facebook group or under my own Mark D'Antonio. And I show you Measure 16, which is the Eagle Nebula here. I show you the Gamma Cygni Nebula, which is the nebula around the center of the Northern Cross, and Cygnus, the swan. And I also show you something else. What did I show? Oh, the North American Nebula. But it's a very different looking North American Nebula. It actually has a very three-dimensional look to it. You can see how the different layers are laid out in it. It looks really pretty.
The one you showed me?
Yes. Yeah.
So that's a very, really good, cool, kind of different image of North America and the Pelican.
Yep.
A little more subtle, but the highlights really stand out on it.
Oh, yeah. Yeah, so go check that out, guys. It's up there at full resolution, so you can, I believe, take it down. I don't think they have a problem with that. Look, Ray. Ray says there's a giant spider preventing us from going to Cygnus. You can see this is another region of space where this dust has literally, it's everywhere in this image, and you can see it's over here. Okay, you can see it's all in here, and this star here is having its blue light scattered by the dust that's in this dark cloud of dust. Okay, which is three-dimensional between us and there. And then right here is actually a void where you can see the stars through this dust. A very fascinating little nebula, because as we zoom in, check it out. You can see through this dust cloud to what's beyond.
It's my favorite part of it.
It is, yeah. Mine too.
Like windows seeing.
Yeah, it's exactly right. It's a window. Yep. It is like a window. Now as we zoom out, here's the full view. Everything that looks kind of reddish brown, that's dust in here. And let's see. Uh-oh. Hey, watch it there, Darrow.
Sorry.
No, nonsense. I'm just kidding. So let's do this. And then let's bring this back.
I have been at war with myself this summer.
Why?
I never really seem to adjust to daylight savings time. The shift.
Yeah.
I mean, I tell myself I should go to bed at 12:30, and yet I'm finding myself staying up till 1:30, and I'm still eating an hour later too.
Well, for the record, it's 2:30 for me right now.
Yeah.
Okay, we're going to do 13 exposures here and move on to our next object. Okay, iris. Save exactly as seen. Okay, they're saved, and we're not going to waste any time because we are going to the stars. Going to the stars, folks. Going to the stars. And where are we going? We are going to the Veil Nebula.
Uh-oh.
I love the Veil Nebula. You can't tell me not to go there. And it's 60 degrees up, so it's going to be fine. This is one that I first saw here on the front lawn in my telescope observatory here. There it is. Look at that beautiful arc. I saw this for the first time here. I was absolutely floored. It literally took my breath away. So this is for Michael Hedrick out there. Michael Hedrick, since you're having such excellent experiences with the objects tonight, I'm going to show you one that is so colorful that you're not going to believe it. Go ahead, Daryl. I'm sorry.
Oh, this is the face portion.
Yes. This is the Eastern Veil.
Kind of like the old drawing of Alfred Hitchcock at the opening of the show.
Yeah,
Except
yeah.
this one has a pointy nose.
Yeah, yeah. Okay, this is going to be a 28-second exposure. We're guiding. I'm going to wait for the guiding to stabilize. Okay, we're stable. And now we'll come out of this, go into the live stack, and just there's the last iris. The iris is saved up there, so that's all good. And you'll see more detail once we get it out there. Okay, and here comes the nebula. This is for you, Mike. You like colors? You got colors, man. Bam! Look at that. Oh man, never fails to impress. Never fails to impress.
See the face, folks?
Yeah, the forehead,
yeah,
eyebrow, eyes,
nose,
pointy nose,
mouth.
This looks like Alfred. Looks like Alfred Hitchcock here. Okay.
It's like a left silhouette.
Yeah, it is. Look at all the stars. There's so many stars in this image, and these filaments are so gossamer. Let's zoom in and make sure that we don't have to stop and refocus. No, we don't. Temperature is 34 now, so it's gone by 2 degrees. So technically we could refocus, but I just wanted you to see. Now, this beautiful, gorgeous nebula was born out of all the fire and fury that the universe can muster. It was born from a supernova. You'll see, if you look a little to the right here, you'll see there's more stuff out there. Okay. And as the summer approaches, we'll do a mosaic of the entire Veil Nebula. Yes, Gladys, it is so pretty.
I think it's kind of sinister looking myself.
Well, it was born of the highest temperatures the universe has to muster, almost.
Something about the nose and the way he's grinning. Somebody in the chat said it was like Voldemort if he had a nose.
Yeah.
Gladys
You calling this
that.
the mouth?
Yeah.
Yeah, so it's like the Joker's grin.
Oh, the bright line in his mouth, that's like the... either if his lips are together, that's the grin, or that's the line between his upper teeth and his lower teeth. If his lips are open.
I think... Consider these his teeth right here. This is the lower lip right here, if you want to call it that. This is the upper lip. And so you actually see a square tooth. Let's zoom in.
Uh, Joker might be
Look
happy
at
too, I guess.
look at this. Look at all that filamentary structure. There's a whole. I think we did a SkyTour radio on this as well, talking about shock waves from supernovae, the speeds at which the supernovae moves out, and what happens when they impact other gases out in the interstellar medium. This gas you see here, some of it came from the original supernova, which occurred somewhere over here, and there's another side of this way over here more that you can't see yet. And but some of it might be gas that it just collided with as it snowplowed into it, and as it did, it heated it up to potentially millions of degrees, and in so doing, it ionized it and caused some of these additional some of these gases you see here. So we have hydrogen for sure in the red, and we have oxygen in the green. And you might say, why do we always see red and why do we always see green? Why don't we see purple or chartreuse or something else? Well, keep in mind, hydrogen is the most common element in the universe, most abundant. And then keep in mind also that oxygen is the third most abundant element in the universe. So it would stand to reason we'd see hydrogen and oxygen most of all, and they would dwarf anything else that's out there.
Yeah, I think when
And
we talked about this before, that's a shock wave.
Yeah. And the thing is, interesting stuff. You see how spindly these look and how they seem to intertwine? Same on the western veil, which is the other side of this. Why would these filaments be like this? It's possible that what's going on in this supernova remnant, it's possible that in this supernova remnant, which I'm going to actually show you, I'm going to ditch the telescope for a minute, all right, and be able to show you the whole thing. It's possible that there's electrical currents being generated in here through the collisions. And if there's electrical currents being generated, then what's happening is that these objects here are these tendrils they're being shaped by electricity that's in the interstellar medium. It just happens to be electricity that's very diffuse, but when you have a single strand of gas that's charged, there's nothing to change that. So it will remain charged for a long period of time. And this is known as the Eastern Veil because it's on the eastern side of the Veil Nebula. So this will be called Veil Nebula East. All right.
You're not turning into one of those electric universe guys, are you?
No, I'm not turning into an electric universe guy. Yeah.
There's another well-known astronomer on YouTube whose name I will not speak. He is really big on electric universe.
Yeah, I'm not an electric universe guy. Well, there's a beautiful nebula for tonight. Isn't that something? Wow. Let's go do a little survey real quick here. Wow, look at how gossamer those tendrils are. Yeah, look at that. Amazing. Absolutely stunning. Wow. We're seeing this way better than we have in the past. I think this is one of our better images.
Uh-huh.
Just stunning. Okay. Beautiful, beautiful. Wow. Now you're also seeing it in 3D, remember? So it's going to be like this. So some of it's moving out this way, some of it's coming toward you, some of it's going away from you, maybe around a spherical front. That's a roughly spherical front coming off of the original location where the star exploded. So you're seeing a thickness of material there. You're not just seeing a solid band. You're seeing something that's extended into the page, out of the page, at you.
Izabela said earlier that she thought the mouth and lower jaw section are closer to us.
It could be, but it's
What's
in
interesting when you
3D.
look at that part, it's like at almost a right angle to the curve of the rest of the shock front.
Yeah. Wow. All right. Well, this is Veil Nebula East, guys. We got 21 shots. We're gonna save these. Save it exactly as seen. And that'll be up there in the next few minutes. Okay. And now, this is what you see in the telescope. In a big telescope, this is what you'll see. And that image belies what you would actually see if you took a long stacked image of it, which is what this is here. Amazing, huh? So that said, that's what we get. All right. Well, I hate to say it, but I'm going to go to bed because I got to get up tomorrow. But I hope you guys had a fun time, and as time goes on, we'll get to see many more objects out here and so forth. But I hope you guys enjoyed it tonight. It was really a lot of fun. This was a great journey with all of you. Make sure you check out our store on Etsy up here if you can. Also, it'd be wonderful if you could join our Patreon. We'd love to have you. Okay, the Patreon is something that can gain you many benefits by looking at all of our images, and you can get some swag from our Etsy store as well. So check it out, will you? And as always, it's been wonderful having you here. And if you go out, just keep looking up. All right. So we'll see you the next time. All right. So good night.
Good night.
Have a good night. See you.
Good night, everybody.
See you later.